Hey there and welcome. Today, we're going to pull back the curtain on a system you've probably never even heard of, but one that has totally shaped the modern workplace. It's kind of like a hidden language that measures, predicts, and defines pretty much all human work. So, you ready? Let's crack the code. Seriously, think about it for a second. How long should it take to assemble some new gadget or pack a box, or even just make a cup of coffee? You're probably thinking, well, that's easy. You just time someone doing it, right? But what if I told you there's a much more scientific, much more universal way to get that answer?
Yeah, that's right. Instead of just watching and timing somebody, there's a system that breaks down any task into its most basic human movements. It's not really about the clock. It's about having a blueprint for the work itself. Now, to really get why this whole system was even invented, we've got to look at the old way of doing things. Just standing there with a stopwatch, timing a worker. It seems simple, it seems logical, but it is packed with problems. Okay, so check out this contrast. Just timing someone is totally subjective. I mean, is that person you're timing naturally fast or slow? Are they having a good day or a bad day? The results are going to be all over the place, super inconsistent. But a predetermined system, it's standardized, it's consistent. And here's the real kicker. You can use it to calculate how long a job should take even before anyone has ever done it before. How cool is that?
So, all of that brings us to the solution, a completely different way of looking at work. And it's all based on this one simple but really powerful idea that all complex work is just a series of simple, basic motions. And here it is. It's called a Predetermined Motion Time System, or PMTS for short. The best way to think about it is like Legos, right? Every single job, doesn't matter how complicated it seems, can be built from a standard set of small, simple bricks. Well, in this case, the bricks are basic human motions, and each one of those tiny motions has a standard time value already assigned to it. And the process itself is incredibly logical. First, you just break down whatever the job is into its tiny, fundamental movements. Then you look up the standard time for each of those little movements in a data table. And finally, you just add them all up. Simple as that. You've literally built a time standard from the ground up, brick by brick. Now, this idea wasn't just some abstract theory. Nope, it became a full-blown system. And the very first one, the original, the one that kind of started this whole revolution, is known by just 3 letters, MTM. And just to give you a sense of how foundational this is, look at the date, 1948. This system was released all the way back then. So this is not some new tech trend, okay? This is a core principle of industrial engineering that's been around and been refined for decades. So yeah, MTM stands for Methods Time Measurement. It was the absolute pioneer that created this universal language for work, and it's still used today in a bunch of different variations, each one tweaked for different kinds of tasks. So what does this language of work actually look like? What are these basic Lego bricks we're talking about? Let's zoom in and take a closer look at the actual components. Okay, so MTM organizes all these motions into different levels. At the most basic level, you've got MTM1. Think of these as the individual letters of the alphabet: reach, grasp, move. Then, at the next level, MTM2, those letters get combined into simple words like get or put. And then you go up another level to MTM3, and you get even more complex phrases like handle. It all builds on itself. Let's make this real. Think about picking up a pen from your desk. The very first thing you do, the first building block, is reach. That's the motion of your empty hand moving towards the pen. Next up, you've got grasp. That's the actual action of your fingers closing around the pen to take control of it. And finally, there's move. That's you transporting the pen to wherever it needs to go. Reach, grasp, move. You see, with just those 3 super basic elements, you can start to build and measure thousands of different manual tasks. It's kind of brilliant. Okay, so this is all really fascinating from, a technical, nerdy standpoint, right? But what's the real-world impact? Why does a system from 1948 still matter so much in today's factories and warehouses and workplaces all over the world? Well, here's the bottom line. A system like this gives everyone a common, objective language to talk about work. It means things like pay rates can be set fairly based on the actual task, not on who's doing it. It means companies can design and figure out the timing for an entire assembly line before a single part has been built. And it creates a hard, data-driven baseline you can use to prove whether a new process is actually better and more efficient. It just takes all the guesswork out of making things better. And look, it's not just me saying this. At its core, like the International Labor Organization puts it, It's all about using the time values for basic human motions to build up the total time for a job. It's a really powerful bottom-up way to truly understand work. And that leaves us with a pretty fascinating question to chew on, doesn't it? We've gone from a simple stopwatch to a system that can catalog and time every single tiny movement a person makes. So if every single motion can be broken down, measured, and optimized, what does that really mean for the future of human work and our endless quest for efficiency? Something to think about. Thanks so much for joining me.